Hello, my rubber hearts. Welcome back to another episode on all things rubber. 3D printing has become a transformative technology in manufacturing, allowing for the creation of complex and customized products. While true rubber, a thermoset material, is not suitable for 3D printing, rubber-like materials have emerged as popular alternatives. These materials offer flexibility and elasticity similar to rubber, enabling a range of applications. In this video, we will explore how rubber-like materials are used in 3D printing while real rubber cannot be used, and the future of these materials in the industry. Rubber-like materials in 3D printing are often referred to as elastomers. These materials mimic the properties of natural rubber, such as flexibility and elasticity, but are thermoplastics rather than thermosets. The key difference lies in their molecular structure and behavior under heat. Thermoplastics can be melted and reformed, while thermosets, like natural rubber, cannot be remelted once cured. This characteristic makes true rubber unsuitable for 3D printing, as the process typically involves melting and layering materials. An analogy can be drawn between rubber and rubber-like materials, and the comparison between meat and plant-based meat substitutes. Just as plant-based products aim to replicate the texture, flavor, and appearance of meat without being meat, rubber-like materials provide the flexibility and resilience of rubber without being rubber. They are designed to offer similar tactile and physical properties while being compatible with 3D printing technologies. The primary reason real rubber cannot be used in 3D printing is its thermosetting nature. Thermoset materials undergo a curing process that creates strong chemical bonds, giving them excellent durability and thermal stability. However, once cured, they cannot be melted or reshaped, which is fundamental requirement for the 3D printing process. In contrast, thermoplastic elastomers can be repeatedly melted and reformed, making them ideal for 3D printing applications. Additionally, the high viscosity of rubber compounds and the need for vulcanization, a chemical process that enhances the elasticity and strength of rubber, pose further challenges. Vulcanization typically requires high temperatures and pressure, conditions that are not compatible with most 3D printing processes. These factors make it impractical to use actual rubber in additive manufacturing. Rubber-like materials in 3D printing are used in a variety of applications, ranging from consumer products to industrial components. For example, these materials are popular in the production of custom wearable devices such as wristbands and insoles, which require flexibility and comfort. In the automotive industry, rubber-like materials are used for creating gaskets, seals, and vibration dampening parts, benefiting from their ability to withstand stress and deformation. One of the major advantages of using these materials is the ability to create complex geometries that are difficult to achieve with traditional rubber molding techniques. This is particularly useful in designing lightweight, flexible components with intricate internal structures such as shock absorbers and flexible joints. The future of rubber-like materials in 3D printing is promising, with ongoing advancements aimed at improving their mechanical properties and expanding their application range. Research is focused on enhancing the durability, elasticity, and biocompatibility of these materials, making them suitable for more demanding applications, including medical devices and high performance industrial parts. Moreover, the development of multi-material 3D printing technologies, which allow for the integration of different materials in a single print, opens up new possibilities. This could lead to the creation of components with varying stiffnesses or flexibility within a single part, further broadening the scope of applications for rubber-like materials. While true rubber remains incompatible with 3D printing, due to its thermoset nature, rubber like materials have filled the gap, offering similar properties with the added benefits of 3D printability. As technology advances, these materials will continue to play a crucial role in additive manufacturing, providing innovative solutions across various industries. We look forward to seeing how these developments will shape the future of manufacturing and design. Stay tuned for more insights into the exciting world of 3D printing and material science. Don't forget to share, like, and subscribe, and I will see you in the next episode.